Good morning, YouTubeistas, Pythonistas, friends. I'm back to talking about a digital mathematics curriculum. It's called that because we don't deny ourselves access to computers, programming, all the way through the curriculum. We can use programming and digital computers anywhere. And so there's a lot of focus on learning to code, and that could be with Python, it could be with Ruby. It's up to you to adapt it to whatever language you would like to use. I happen to use Python, but more as an example. I use other languages too sometimes. I think more than one, you can listen to other YouTubes where I talk about more than one is better than one, but not too many in terms of most things in life. Language is included. So once you get to the splash page or home page for digital math, which is in New Zealand, I believe, Wiki Educator, check it out. I'm going to take you to casino math today. I've been talking about that a lot. Now, in my ecosystem or neck of the woods, here's a picture of my friend Elise. That's actually not her car, but she looks really cool next to it. Her husband has worked for a long time. At the time this picture was taken, he was working and continued to work for a long time with this casino, Angel of the Winds. That, by the way, is my daughter's cat, Izzy. I think that's Izzy. Anyway, this is from a trip way back in, 2008. But casinos are big, is what I want to say, in our neck of the woods because the native tribes have been here since Neolithic times, have seen a lot of destruction to their ecosystem, especially the watersheds, because loggers came in here, like Europeans showed up, and basically created pulmonary embolisms throughout the watersheds, meaning that watersheds are like lungs. They have little rivers that get smaller and smaller, and the salmon need to go back there. And they actually nitrogenate, fertilize the the whole ecosystem. And what the logging roads were doing is they just, without a sufficient culvert, if you know what that is, just take a logging road and cut it right across a salmon little rivulet, and maybe put a pipe in for the water, but not really think about the fish and how are they going to get home. So there was a lot of destruction, and the casinos in this area, Stillaguamish, Grand Ronde, Tulalip, and so forth, they've been doing a lot of work to help restore the environment, which means restore health to the ecosystem, the supermarket. So I don't have the negative connotations a lot of people do around the very term casino. But once we're beyond the cultural differences there, you can call it what you want. The whole idea of what do we do next or what is going to happen next, that is critical, right? Probability, but also classical physics, mechanics, ballistics. It's all about, if I dial in these parameters, how can I make this event happen in the future? Maybe you're trying to blow something up, right? It's demolition engineering, as you might say war is all about. Not saying it's always used for good purposes, casino math, and therefore back to what we're talking about, the sort of ethics. I'm not against discussing, the damage that happens because of gambling in people's lives and all that. But it's almost like it's a very psychological thing. Your innermost thinking is about calculating what behaviors you can get away with, you could say, or what should I do next to help people. Whatever your way of thinking, you're always calculating or computing or deciding what to do next. So there's no getting away from the fact that there's a huge what should I do next component to life. And I'm not against saying, sometimes listen to your heart and stuff like that. Those kind of lessons are not just stupid. But when we play games or design games, or even more important, create models, simulations of the world, first of all, here's where programming comes in, Pascal's triangle. You get the number of relationships between any n dots. If you connect one dot to all the other dots, how many connections are there total? Like if you're talking about how many ways are there for people to shake hands. If 10 people go into a room, Well, one person can shake hands with 9 other people. And a shaking hands is a bidirectional thing. So once I've shaken your hand, you've also shaken my hand. And if there are 10 of us, then I can shake hands with 9 other people, and that happens 10 times. So 10 times 9, there's 9 other people that can shake the guy's hand or her hand. But then slash over 2 because bidirectional. So 9 times 10 is 90 over 2 is 45. And that's one of what we call the triangular numbers. And it actually appears in one of the columns of Pascal's triangles here somewhere. If we look, now this is not a triangle, so it's not really showing very well. But the triangular numbers are there. I could dive down that rabbit hole. Programming dice, programming card games, cryptography, I put more into supermarket math when you're trying to protect the privacy and reliability of communications. Because cryptography isn't just about protecting against malfeasance or against somebody intercepting and decrypting. Cryptography also has to do with keeping communications robust by putting like little checksums in there and things like that. Because there's the problem of noise, and if you can encrypt and decrypt in not just any file format is a way of encrypting or encoding. So encoding, that's an important aspect of this curriculum too. I'm not going to go over all the history of casino math. I just would rather expand your minds to where you're including pretty much any math topic, because so much of math, and as I said, including classical or any physics, is about, given this in the past, what can we predict maybe only a millisecond from then, or a nanosecond. If we have a working model, like the standard model in physics, we know that if this particle and this particle with this energy at this angle or whatever come into collision, then the likely outcome of that. So particle physics is about probability. The future, as predicted by what's happened up until now, that's what casino math is all about. And you can see how if we're risk averse, maybe too much risk averse, and don't make the investments we need to, we pay the price. And for example, I would say Martian math, which is a thin disguise over the Bucky stuff, not including that in our current curriculums for the most part, I think that's very risky. For one thing, it opens us to why, and that undermines the authority. Remember what happened during the Renaissance. People discovered that not everything was known in the past. There is still stuff to be discovered. So we need to keep that open-mindedness, or there could be, negative consequences there in terms of just, why didn't you teach us this when you could have, that kind of stuff. So casino math is also related to investing in possible futures. So this is where we would get into the whole idea of charitable giving. You could go from casino to the idea of, if you win a video game like here in Oregon, the Oregon Lottery, commit your winnings to some government program. That would like flip the table. Because the way it is now, if you win, you get the money, and usually you don't win, and the state gets the money, and the state decides where the money goes. And I'm proposing another kind of game where if you win, you get to decide what charitable cause out there you want to give the money to. But you can also have that go on your profile so people can get to understand you and your character based on your giving pattern. And that can be in itself almost like a resume credential. You can, if people start to appreciate your pattern of investment, that can be good for you. So in a way, you're investing in yourself and your character when you play these charitable giving games, which I am connecting to the Coffee Shops Network and other videos if you've been watching those. All right, I'll let you go. Again, 4 chapters, or four, I wouldn't call them chapters, four broad characteristics, aspects of digital math. And this is the casino math component that I've just been going over. Please take a look at my other videos if you want to see more about, say, Neolithic math. Again, I don't teach the concepts in great detail in these videos, at least the recent ones, because I'm trying to give just the overview, the 10,000 view, 10,000 foot view, and not get into a lot of nitpicky details. But Pascal's triangle, that is important. Okay, talk to you soon, Ed.